let's do the additional practice problems part 2 for chapter 7 in chemistry. So number 1 has 3 parts, and the chemical reaction is that you have 2 sodiums plus sulfur plus 2 oxygens will give us sodium sulfate, Na2SO4. Okay, and then the question says that we want to make 10.0 moles of sodium sulfate, and then the 3 parts are how many moles of sodium would you need, how many moles of sulfur would you need, and how many moles of oxygen would you need. So we'll just take those one at a time. So because this Na2SO4 is already in moles, we can go right into using stoichiometry and just looking at the ratio. So we want to make 10 moles of Na2 SO4, and if we look at, let's do sodium first. So part A is sodium first. There are 2 sodiums for each 1 sodium sulfate. Okay, so the sodium sulfates are going to cancel, and 10 moles times 2 is equal to 20.0 moles of sodium. And 3 significant figures because this has 3 significant figures. Okay, so that's part A. Part B then asks, if you're going to make 10 moles of sodium sulfate, how many moles of sulfur would you need? Okay, so again, 10 moles of sodium sulfate now there are, for the sodium, there is one sulfur, not sodium, 1 sulfur for each 1 Na2SO4. Okay, so that's going to be exactly 10 times 1 divided by 1 is 10. So the Na2SO4s cancel, and you will have 10.0 moles of sulfur. Okay, so let's go ahead and erase that. And then part C, we want to know how much oxygen will be used. How much oxygen will be needed to make 10 moles of sodium sulfate. So again, 10 moles of Na2SO4. And for oxygen, there are 2 oxygens for each 1 Na2SO4. Okay, so the Na2SO4s cancel, and 10 times 2 is 20. So 20.0 moles of oxygen. Okay, so again, to use stoichiometry, it has to be in moles. Everything, we were given moles so that we could go right into looking at the ratios between the different components within the chemical reaction. Okay, number 2 says hydrogen is made in the following reaction. We start with magnesium. We add 2 hydrochloric acids, HCl, and we get magnesium chloride plus hydrogen gas. Okay, so just as an aside, you may recognize this as a single displacement reaction. So basically the magnesium and the hydrogen switch places. So the magnesium was by itself, and now the hydrogens are by themselves, and the hydrogen was bound to the chloride, and now the magnesium is bound to the chloride. Okay, so this says you're going to add 15 moles of HCl to an excess of magnesium, and that bit of information is just given to us to tell us that magnesium, if it's added in excess, that tells us that it is not the limiting reactant. And then the question is, how many moles of hydrogen will be produced? So how many moles of hydrogen? That's what we want to find out. Okay, so again, the HCl is in moles, so we can go right into looking at how many moles of hydrogen get produced then with 15 moles of HCl. So if we start with 15 moles of HCl, and there is 1 mole of hydrogen gas for each 2 moles of hydrochloric acid. So the hydrochloric acids are going to cancel, and you'll be left with moles of hydrogen gas, and 15 times 1 divided by 2 is 7.5 moles of hydrogen gas. And 2 significant figures because the 15 has 2 significant figures. So that's, again, one where you started in moles, so you can go right into using the ratios of stoichiometry. Okay, number 3, for the following reaction. So let's go ahead and write the reaction. 3 sodium hydroxides Okay, so here's our reaction, and it says how many grams of H3PO4, so how many grams of this are needed to make 100 moles of water? Okay, so the only thing that we have any information about is the water, and we know that we have 100 moles of water, but that's good because that is already in moles, so that allows us to begin by looking at the ratios between the water and the H3PO4. This question asks us nothing about this or this, so we can ignore those. Okay, so we have 100 moles of water. And we are interested in the H3PO4, and we can see that there is 1 H3PO4 for each 3 waters. Okay, so waters cancel, and you'll be left with moles of H3PO4. So 100.0 divided by 3 times 1 divided by 3, we can have 4 significant figures. So it's going to be 33.33 moles of H3PO4. Okay, so now we know the moles of H3PO4, but the question asks us grams. So now it's just a matter of converting those moles to grams. Let's erase this and give us some space. Okay, so we had 33.33 moles of H3PO4. Okay, we want to convert that to grams, so we need to know how many grams is in a mole of H3PO4. So it's going to be 3 hydrogens, 1 phosphorus, and 4 oxygens. Make sure that people don't think that is so it's 4 oxygens, not the number 40. So each hydrogen is 1.01. So it's 3 times 1.01. Phosphorus is 30.97. Getting these from the periodic chart, and the 4 oxygens, each oxygen is 16.00. So if we add all of those together, you end up that 98.00 grams is equal to 1 mole. Okay, so we are moving from moles to grams, so the grams is going to go on top. So 98.00 grams is 1 mole. Okay, so moles are going to cancel, and then 33.33 times 98 with 4 significant figures will give you 3,266 grams of H3PO4, hydrogen phosphate. Okay, so that is number 3. Okay, number 4 says, consider that copper is made according to the following reaction. So 2 aluminums plus 3 copper sulfates, CuSO4, will give us Al2S3O12 plus 3 coppers. Okay, and then it says if a chemist uses 100 grams of aluminum, so 100 grams of aluminum, 100.0 grams of aluminum, and excess of this, so again, that's just telling us that the CuSO4 is not the limiting reaction. How many grams of copper will be used? Okay, so that's the question we want to answer. Okay, so for this one, remember, you can only use stoichiometry. You can only use the ratios if you are in moles. So the first thing we have to do is this is the only value that we know. So that's all we have to work with. We're not asked anything about this or this. We can ignore those. We're just concerned about the aluminum and the copper. Okay, so the first thing we have to do is change those 100 grams of aluminum into moles. So 100.0 grams of aluminum. And if we look at the periodic chart, you will see that we're going from grams to moles, so moles will be on top. 1 mole of aluminum is equal to 26.98 grams. Okay, so grams are going to cancel. We'll be left with moles of aluminum. And what you get for that is 3.706 moles of aluminum. Okay, now that we know the moles of aluminum, we can use stoichiometry to look at the relationship between the aluminum and the copper. so 3.706 moles of aluminum. And there are 3 coppers for each 2 aluminum. Okay, 3 coppers for 2 aluminums. So 3.706 times 3 divided by 2 will be 5.559 moles of copper. Okay, because the aluminums are going to cancel. That cancels, so you're left with moles of copper, and 4 significant figures, 5.559. Okay, then the last step, so now we know the moles of copper, but we don't know grams yet, so we can now make that conversion from moles to grams. So 5.559 moles of copper. So we're going from moles to grams, so grams is going to go on top. And if you look at the periodic chart, you will see that for copper, 63.55 grams of copper is equal to 1 mole of copper. Okay, so moles will cancel. We'll be left with grams of copper, so 5.559 times 63.55 is equal to, with 4 significant figures, 353.3 grams of copper. Okay, so our answer that we started out to find is 353.3 grams of copper. Okay, so this was a case where we started with grams of aluminum. We first needed to change that to moles. Once we had that in moles, then we could look at the relationship between the copper and the aluminum, looking at the ratios. That gave us moles of copper. Once we had the moles of copper, then we can use the periodic table to convert moles of copper to grams of copper. Okay, number 5, the last one, is 4 NH3s plus 5 oxygens will give us 4 NOs plus 6 waters. If you want to make 15 grams of water, how much NH3 in grams do you need? Okay, so we want to make 15 grams of water. And we want to know how many grams of this. Okay, so again, we don't need to concern ourselves with this or this. We're not asked anything about those two. So we're only concerned with the NH3 and the water for this problem. So stoichiometry allows us to, if we know the amount of water, we could determine the amount of anything else in the equation, but only if we are working in moles. So the first thing we need to do is convert this 15 grams of water to moles. So 15 grams of water, and we're going to go 2 moles. So we're going to, moles will be on top. 1 mole for water is going to be 1 hydrogen and 2 oxygens. So the hydrogen is 1.01 and each oxygen is 16. No, sorry, water is 2 hydrogens 2 hydrogens, and 1 oxygen. So it'll be 2 times 1.01 plus the 1 oxygen is 16. So for water, it's 18.02. 16. Yeah, it should be 18.01 grams is in a mole. And I think I did my math wrong here. So 18.01 grams is in a mole of water. Okay, so grams will cancel. And we'll be left with moles of water, and I'm going to need to do some calculations here, so bear with me. So it's going to be 0.0 with 3 significant figures, 0.833 moles of water. Okay, so 0.833 moles of water. Okay, now that we are in moles, now we can use stoichiometry and look at the ratios between the NH3 and the water. So there are 4 NH3s for each 6 water. Okay, so this is moles of water. So the waters are going to cancel. So 0.833 times 4 divided by 6. Will give us 0.555 moles of NH3. 0.555 moles of NH3. Okay, so now we know the moles of NH3, but we were asked for grams. So now we just need to make that conversion using the periodic chart. So 0.555 moles of NH3. I'll go ahead and erase this. So then we look at our periodic chart, and NH3 is 1 nitrogen and 3 hydrogens. So it's going to be 3 times 1.01, and the nitrogen is 14.01. Okay, so it's going to be 17.04 grams in 1 mole. Okay, we're going from moles to grams, so grams is going to go on top, 17.04 grams in 1 mole. Okay, so moles cancel, and 0.555 times 17.04. With 3 significant figures, our answer is 9.46 grams of NH3. So up here, the answer that we get was 9.46 grams. Okay, so again, we started with grams of water. To use ratios within the equation, we needed to convert, we got to get into moles, so we converted these grams of water into moles. Once we knew the moles of water, we can use ratios to determine the moles of NH3. Once we knew the number of moles of NH3, we use the periodic chart to determine how many grams is in 1 mole of NH3, and then use that to convert from moles of NH3 to grams of NH3. Okay, that is it for the questions, part 2 of additional practice problems, chapter 7.